This example shows how to create objective lens of scanning electron microscope. This lens was presented by Eric Munro in Handbook of Particle Optics. In the edit window we will see the resulting design which we want to obtain. We will start from new input file. We are creating magnetic lens. The size of mesh is not important now because we don't know precisely where the DXF file created by CAD program by the constructor will be positioned. So we start from the predefined mesh boundaries. Now we want to import the DXF file to the background of the edit window. It is able to do it from the display menu. We have prepared object type DXF file, so we import it into the PD. It reports that for entity was read from the file, and here are the dimensions of the design. Now we will display the design in colors. They are presented in the DXF file. Sometimes may happen that the file the design is not correctly rotated and may be shifted out of the optic axis, so we use D3 controls to put design to the proper place. Now we can see part of the lens, so we should zoom to big area to view whole lens. Let's say something like this. Okay, now the X file here and our mesh here. We should move mesh to the proper position, so we use mesh and shift mesh about, let's say, 8 millimeters to the left. So it is okay, and we can start to create coarse mesh. First we can snap to the background file entities. So when we select some point and try to move it, it snaps to the entities and we can move on them. We hold Control key, the point snap to the end of the entities to the corners, which is important for us. So we'll start at this point, use Control select another point and move this line to the perpendicular to the edges using move points to the horizontal or vertical line. We can also align other points on the vertical coarse line, and we have the fast line. Now we can move this into the proper position and make it perpendicular. Now we will need another core lines here, and on the other place, so we should create some new one. Hold Control key and click on the coarse mesh line, so both points were selected, and now I can create some new vertical line. here is information window that coarse mesh for was recalculated. Now I can move this point here and this point somewhere here. This is the wrong position because I need this point to be here. I can use right cursor K, select another point on the horizontal coarse mesh line and put this point to the position, and now I align this coarse mesh line. Now I can move this point to the corner and align horizontal mesh. Okay, now I can put this point to the proper position. Let's say that we start at the point and we'll align coarse line to be vertical, and also this point. This point can be aligned to this point again. Now I should create the vertical line to the left side of the magnetic circuit. So again, add vertical line. Now we have some errors with problem with fine mesh, because I have not fine mesh different yet. It's something like this. So there are errors reported. We can avoid displaying of this error by setting gap to proper position, but now we will be happy with the situation as it is, and we will ignore errors until we create fine mesh which will satisfy us. So I move this point to the proper position and align whole coarse mesh line. Now it is time to look at this point. Because neither axis it's the best choice to have square fine mesh. We will put the line to the parallel with optical axis. Now we will need to create some another horizontal meshings. Yeah. Now I click to select 2 points, but this point accidentally move, which I don't do, so I can use undo last operation and points are returned back to proper positions, and now I can create some mesh line and put it to the proper position and align it. Okay, now it happens again, so I can move it back and create another point and align it. Oh, now I have mesh lines which can be used to create magnetic circuit, and I have no mesh lines which can be used to define coil. Now I can do proper fine mesh to avoid errors with the recalculating fine mesh. First we will look where is the gap, and it is in the default position for every new input file. We should move the gap into this quadrilateral to have the mesh which is correct in the place where the magnetic flux density is the best. Now this again accidentally move of the point. By right hand mouse button I select the pop-up menu and select this point as a gap. I should edit the gap values. I 10 horizontal fine mesh subdivisions in the gap, and I adjust the vertical fine mesh subdivisions to have square elements in this gap. Now I can calculate fine mesh. Fine mesh have row of points. When we look at the fine mesh, it looks something like this. For the magnetic lenses, it is recommended to use meshes with about 60,000 mesh points, so I can create a little bit denser mesh using, let's say, 30 points in the gap, adding to have square elements, and calculate mesh again. It has about 50,000 points, and it is, let's say, sufficient for us. Okay, we can look at the fine mesh. It is in the region the gap. We can create some another coarse mesh lines to put to proper position the coil. Okay, but I need first a vertical mesh line to move point to the corner, so I should create some and move this point to the proper position and align it to have correct position of all coarse mesh lines. Okay. This can happen when we have snapped to the too big distance, so we can edit the distance holding Control key and clicking on snap button. Now I can set snap distance to the little bit small, let's say 2 millimeters, and create another fine mesh. Now you can see that on the distance 2 millimeters I can snap to the TXF entities on the background. Now I move only this point to the horizontal position, because this should have the rest of the line should have this direction, because coarse mesh be regular. Okay, now need this vertical fine mesh to have coarse mesh to define the core. Okay, we have coarse meshes and can fill materials into the mesh. Now when we look here, this position is not correctly set the coarse mesh line, so I will move it a little bit down using a snap function. and put the whole line to the correct position. Now it is okay. We can save the design because we have done a lot of work. Now it's time to start to fill materials. We will switch to the fill material properties regime and create some new magnetic material. We will set the name magnetic circuit and the magnetization curve we will left on the general iron. Now we can fill the magnetic material using double click in the region where the coarse mesh is denser. We can zoom and fill in, or we can select holding control key little bit more points, right and mesh button and select properties. Okay. Oh, select empty magnetic material and put it back, or we can use undo operation. Okay, now we will create some coil, rename it, set the excitation to the ampere turns and create new excitation, let's say 500 ampere turns. Okay, and put coil into the mesh. And we will see design again. Now it is it's time to start calculation of the magnetic field. First we look at the description and properties. We will create only linear calculation, so without saturation of magnetic materials. Okay, save and add the new file into the project. Let's import it into the project and calculate it. Here is the result of the computation of the lens module of EOD. Now we can display this lens in the output window. Right hand mouse button and new output window. First we select material. Object type is the original input file. We have DXF imported. It is our input file. In output, we want to show it in the legend. Display coarse mesh, magnetic materials, coarse, and also the legend about these materials. Now we will see the lens in the out window. We can look at the saturation of magnetic circuit. Here is how the saturation looks like, and the saturation in the Tesla. We can display also these lines of the magnetic flux, or display axial flux density. Okay. Also display axial flux density in the plot windows. Open plot and the axial flux density, also with the maximum density, position of the maximum, and the width of in the half of height of the maximum. Okay, now the project which will guide us in the importing lenses using the Excel file is at the end.